Building one AI agent is manageable, but what happens when multiple AI agents need to collaborate together? That's where LangGraph becomes extremely useful, and today I'll explain it using a real production style AI project. This project is a multi-agent financial AI system. Different agents collaborate together to analyze earning reports, market data, and investment risk. This is one of the most important parts of LangGraph, the shared graph state. Think of it like shared memory between all AI agents. Without shared state, every AI agent behaves independently. But in multi-agent system, agent needs shared information. That's exactly what LangGraph helps manage. Each variable inside the agent state represents shared information. For example, the retriever agents may add filling text. The market agent adds stock data. The risk agent adds bearish analysis. And finally, the generator agent creates the final report. Without LangGraph, developers manually handle state passing, agent routing, workflow control, and orchestration logic. This becomes difficult very quickly as systems scale. Hey, so you have probably been building AI apps with LangChain, right? It's awesome for basic stuff, but have you ever felt like your agent is just doing a one-way trip, like it does step A, then step B, then it's done? But what if the AI realizes made a mistake at step B and needs to go back to step A? That's where the linear chain life falls apart. Enter LangGraph. Think of LangChain as a conveyor belt. Everything moves in one direction. It's simple, but it's rigid. LangGraph, that's your entire factory floor. Instead of a straight line, you're building a map of how your AI thinks. And the best part, it can look back, make decisions, and actually remember stuff along the way. To build this factory, you only need to know three things. Keep it simple. The state. This is the whiteboard in the middle of your factory. It's where your app writes down everything it's learned so far. Every node can see it and update it. The nodes. These are your workstation. Here A, B, and C. Maybe one node is researching, and another is drafting, and another is checking for errors. Each one takes the info from the whiteboard, does its specific job, and updates the board with the result. AJs. These are the conveyor belts. They connect your workstation, but here's the magic. You can have conditional AJs. They are like smart sensor on the belt. They look at the whiteboard and say, this draft has too many errors. Let's send it back to the drafting node. Or, this looks great, ship it to the end. Why bother? Because real world AI isn't a one shot deal. Whether you're building a customer support board that needs to verify an order or a research agent that has to iterate on a summary until it's perfect, you need these stop loops. LangGraph lets you handle those wait, let me try that again moments without your code turning into a giant unreadable mess of if else statements. If you want to see how to actually code the first node for this, drop a comment below and let me know. I'll show you the basic boilerplate. Let's stop building linear boards and start building agents that can actually reason. Catch you later.